Hello everyone, welcome to our channel Techlteworld. So today's topic that we are picking is a very basic topic, okay, but we must understand this topic to understand the layer one, or you can say the physical layer in a very proper manner, okay. So today I have picked the topic modulation, which is one of the topic which everyone have gone through this topic in our engineering, okay, like second third year, okay. So today also I will go with the basics, okay, not on a very high level, but yeah, I'm planning to have multiple videos in modulation, okay. So today basically I will go with a few of the like you can say the definition, okay, types of modulation, and why required, okay, advantages, okay. So these are the things basically we are going to discuss today, and that also on you can say very basic level, okay. And further we will go, I will have the video, I will create the video on a very in-depth basis, okay. But yeah, this is for you can consider as a beginner one, okay. And to understand this word in a very layman language you can say, okay. So once I will go with the type of you can say modulation, okay. So in that, for each type I will go in a very deep, okay. So if I'll give a little bit preview, okay. So I will go with the definition, but yeah, let me just write it what are the types, okay. So in that we will be having analog and the digital modulation, okay. And further the analog will be divided into you can say the amplitude modulation, frequency modulation, phase modulation. This all you have heard this word in your engineering time, okay. But yeah, I'm just making it like a kind of revise you can say, okay. And in this ASK, like amplitude shift keying, frequency shift keying, okay, phase shift keying, and further I think there are different modulation schemes that we are using in our regular you can say the telecom or the radio activities, okay, in a regular telecom world, that is different quamps, okay. Based on that the throughput and everything is dependent. So different quam, if you remember, like QPSK 16 quam, 64 quam, 256 quam, okay. So for every all this thing, the quams which we are discussing, so the complete the base is on this particular technique, okay. So let's just start the video. Sorry that I have taken a bit more time on this, but yeah, so I have already mentioned that we are going to discuss from the basic, okay. So first of all we need to know that what exactly the modulation is, okay. So what is a modulation, what in a layman language, okay, what do you understand by this? So if it is simple, if you'll take an example, suppose I have a letter, okay. I have a letter and I have to send it from A to B point, okay. So definitely I need someone who will carry this message or this letter from point A to point B, okay, without having, I can say, distortion and all, okay. And the single letter we can't easily move it to much more distance. Okay, so for that particular we required a carrier who will carry or require a postman, okay, who will pick this, okay, and then further we will put it in any of the transportation, okay, bus, train, plane, on any of the thing. And finally, so this particular point, okay, so taking it, okay, the postman takes a letter from you, okay, so it will act as a carrier, okay, or you can say it will put a stamp and all, and here it will modulate, okay, put it in a carrier, okay, and further it will go and send it to the destination. Here the demodulation, okay, that, okay, finally matching the destination address, and it will give it to B, okay. So this is one of the lemon example in which the message that the letter that we are sending, okay, is the signal that we want to transfer, okay. It can be anything: voice, video, audio, okay, anything, okay. And this need to be transferred to the long distance, okay, and that is not possible if I'll shout, okay, and if you try to transfer this audio video signal, you can't send it, this message without carrier to a long distance, okay. So that's why this message is basically is our original message, okay, and the carrier that we are going to use, okay. So that carrier signal can be like, it can be radio wave or light pulse kind of thing, okay, which is having high frequency so that it can travel to the long distance, okay, without any much more interference and all, okay. So if you summarize, we can simply say the modulation is a process of encoding the information or the original message onto a carrier signal, which you can consider as a courier, okay. That carrier signal can be radio wave, light bulb, okay, because that is having very high frequency and that can travel to a long distance, okay. So but the thing is that we need to we can't directly send the carrier or the you can say directly, we can't put the voice, music and data over that, okay. So modulation is a technique where we will load that particular message, our own message into that high frequency carrier, okay, so that it can travel up to long distance, okay. So if you'll go with the formula, okay, I can write there are a lot of formula, we will go slowly, okay, in multiple videos. So that signal basically can be written as wt phi, okay. So in this way there are this is how exactly we represent the signal, okay. So in this we can see A is amplitude, okay. If you talk about omega, this is frequency, and this is basically phase angle, okay. So these are the three variables, okay, which we can vary and modulate our original signal and we can send. So you can see, means if you go with little bit pictorial, okay, so let me draw a little bit pictorial, okay. So suppose this is our signal, okay, this is our message message signal, you can say, which need to send. So let's consider this will be as a, okay, signal as a carrier. Okay, and we will do the modulation. We will modulate this into the carrier signal. Okay, and then we will transfer it. Okay, so basically what will happen, so in this, that particular signal will get modulated and transfer to the long distance. Okay, so this is what exactly we call it as a modulated signal or modulation. Okay, so it's very simple. See, so that's why we are modulating the message over a carrier. So this can be of multiple type. Okay, it can be in a very uh, various way. Okay, so I already in a formula I have mentioned. Okay, if you'll see the formula, a sine, or you can see we have already written. So in this, what exactly happening, we are varying the amplitude, we are varying the frequency, and we are varying the phase. Okay, so this analog signal. Okay, so we if you go with the type. Okay, so there are basically, in general, we are dividing into two type: analog modulation and a digital modulation. In the analog modulation, we are having these three different types. Okay, amplitude modulation, frequency modulation, and the phase modulation. So by name itself, you can understand that here exactly we are varying the amplitude, here we are varying the frequency, here we are varying the phase. Okay, and in a digital modulation, so we will go with the term. Okay, ASK, FSK, PSK. Okay, little bit. Okay, and I have already mentioned in earlier that I will try to have a separate video on all. Okay, so just bear with me for this basic video. Okay, so this will basically help for the beginner much more. So this is what exactly the modulation and the type that we are going to discuss. I can take a very different example. Imagine that you have already, I have told that you have handwritten letter, okay, with you, and you need to travel it to a long distance in a desert. Okay, so it's very risky that if you send it alone. Okay, so wind can tear it. Okay, so it can got blur, ink got faded, lot of things are there. So in that particular, we will put it, that particular letter, in a caravan, and we will send it safely. That caravan basically act as a carrier. Okay, so if you'll go, the main question comes in our mind. Okay, that why exactly, why we require, why modulation. Okay, so answer for this, that first of all, it can help you to transfer it to long distance. Okay, so let me clear this figure. Okay, so if I'll check with why modulation. Okay, then we have a simple answer on that. Okay, first of all, efficient transmission to long distance. Okay, so basically we can send this to long distance. Okay, second, multiple signal transmission. Okay, so we can send multiple signals at a time. Okay, and the major thing that is, it will improve the antenna size and efficiency, and this is one of the important factor, the antenna size. I will discuss little bit more on that, on the antenna size. Okay, so I will discuss on that. Before that, let me list out few of the things. Okay, noise reduction will be also there, less interference. Okay, so these are the things that why exactly modulation is required. Okay, and you will able to control your signal very efficiently. Okay, so signal control, okay, will be allowed, or you can say the much more uh, easy. Okay, multiplexing is one of the thing. Multiplexing. Okay, so what exactly multiplexing? The modulation, what exactly it will do? Modulation facilitate multiplexing, where multiple data streams are combined in a single carrier wave. Okay, and that can be transferred. Okay, so you can take an example. So this is basically used in like cable, TV. Okay, DSL internet. Okay, so on that particular we are going to use this multiplexing. Okay, so these are the things why we are going to use, why modulation is required. Okay, so one of the important aspect that I want to discuss is the antenna size. Okay, this is one of the important factor. Antenna size. Okay, so let's take an example. Okay, whenever I'm talking about the antenna size. Okay, so if you'll consider the size, the price will also come into the picture, the efficiency will also come into the picture. Okay, and we should make an antenna that should be portable and compact. Okay, so for that particular, see, if the simple thing, the example I can take, for the efficient radiation and the reception, antenna should be what you can say, the side should be very compressible. Okay, as compared to you can say the wavelength of the transmitted signal. Okay, so I think basically with the formula I can let you know. Okay, so as we know, the speech, okay, that we are speaking, or the, so the frequency for that is 20 hertz to, generally, okay, 20 or 40 hertz, 40 hertz to 40 kilohertz. Okay, so let's take an example of 20 hertz to 20 kilohertz. Okay, let's suppose 20 kilohertz speech basically we are sending. Okay, so as we know, see, this is the formula. Okay, of, sorry, this is what exactly the lambda, sorry, this is nothing but our wavelength which I'm talking about. Okay, and whenever we are talking about the that equal to c by f. Okay, c is nothing but the speed of light. Okay, and whenever we are talking about f, okay, so f is nothing but the frequency of the transmitted signal. Okay, so c, if you are telling about the speed of light. Okay, so what is the formula of the speed of light? Everyone know that 10 to the power 8 per second. Okay, and whenever I'm talking about this wavelength, so basically the antenna size is directly proportional to this. Okay, now when I'm telling that antenna size is directly proportional to this, so I have already taken the example. Okay, so let's see here, I have taken the example of 20 kilohertz, correct? So when I'm taking the example of 20 kilohertz, then calculate this wavelength, c by f. Okay, So if you calculate this, convert into 3 into 10 to the power 8 per second divided by 20 into 10 to the power 3 hertz. Okay, that will become 1500 meters. Okay, okay, 15 kilometer. So, and I have already told you this is directly proportional to, sorry, this is directly proportional to length of your antenna. It's, and 15 kilometers is not basically the feasible. You can't imagine this. Okay, so now let's calculate, okay, where we are assuming, okay, the frequency of 100 megahertz. Okay, so we are going to means use the 100 megahertz carrier frequency. Okay, and then we will calculate. Then if you will take the 100 megahertz, you can see, you can do this the same. This is for 20 kilohertz. Now 100 megahertz, take the example and calculate the same thing. Okay, so speed of light 3 into 10 to the power 8 divided by 100 megahertz means this into 10 to the power 6 hertz. If you calculate, it will come as a 3 meters. Okay, so 3 meters antenna size is possible, okay, and feasible. Okay, so now this will be modulated using this formula. Okay, we can have the antenna size of 3 meter, where we are using the modulation technique to send our speech to the long distance. Okay, so hope you understand this with the small example. Okay, so this is why we required modulation. And if we talk about the advantages, the same thing. Okay, so it will reduce the antenna size, multiplexing will be there, increase the transmission range. Okay, so you are going to send it to the longer distance with the less attenuation and interference. Okay, it will improve the noise resistance, enhance the signal control. Okay, you can optimize that transmission based on the distance coverage and all. Okay, and you can enable a lot of technology in that. Okay, so these are basically the advantages. So we'll go with smaller introduction with all this. Okay, type of modulation. So modulation, we already understand, this modulation can be obtained by changing the amplitude, frequency, and the phase. Okay, in terms of analog and in digital both. Okay, so basically we are considering it as a, uh, you can say, the major types. Okay, the major types we are considering as analog, okay, and the digital modulation. Okay, but if you will go, the categorization may vary. Okay, so in a lot of figure you will see that modulation is divided into, you can say, the continuous wave modulation. Okay, and that continuous wave modulation further divided into amplitude. Okay, and the analog will be coming into the frequency and the phase. Okay, so you can see that kind of figure also. And further it will be divided into pulse modulation, and pulse will be divided into analog and the digital modulation. Okay, so where the pulse amplitude, pulse width, okay, pulse phase modulation will be there. Okay, so this is how, means a lot of figure you will see over the internet. Okay, but we'll go with the standard one where we are going to discuss this, and further we are going to discuss much more on that. Okay, so if you want, I can elaborate in that. See, okay, analog modulation, that can be am, fm. Okay, and the phase one. Okay, And digital modulation, you can say, the first of all it will be in a pulse coded modulation, delta modulation, adaptive. So pulse coded, if I'm talking about, okay, in that pulse amplitude, pulse width, which I have already told you, so that will be categorized in that manner. Okay, but yeah, let's focus on the simplified manner which we are going to discuss. Okay, about this modulation today. Okay, so whenever I'm talking about the amplitude modulation, so what exactly in this we are doing in a AM amplitude modulation. Okay, so when I'm talking about the amplitude modulation, so this is your signal. Okay, and we are, this is your carrier signal, this is the signal that you are going to transfer, that you are going to send. Now if you do the amplitude modulation, here we are varying the amplitude and we are modulating the signal. This is what we call it as a amplitude modulation. If you go with the simple definition, it is a type of analog modulation in which amplitude of the carrier signal is varied in a proportion to the whatever the information signals are. Okay, and if you take an example of AM, okay, the radio broadcast, okay, that is basically the the best example for that. Okay, so this is what aim. I will have a separate video further. Okay, I will record the separate video in details for this all this. Okay, so currently I'm going with the definitions. Whenever I'm talking about the frequency modulation, so very simple. This is the analog modulation in which we are varying the frequency. Okay, so in this you can take a simple example, FM radio broadcast. This is the best example in which you can see the input signal can be this. Okay, this is your carrier signal. Okay, and if you are modulating this, okay, so here whatever we are doing, where in place of amplitude we are varying the frequency, you can see. So here we are varying the frequency and doing the modulation. Okay, so this is what exactly the modulated signal for FM modulation. Okay, frequency modulation. Now the phase, when I am talking about the phase, suppose this is your message. Okay, and if you need to do the modulation in this, what exactly we are doing in this is the signal. Okay, and we are changing the phase here. Okay, you can see. So in this particular here, okay, now let me make it clear a little bit so that it will be easy for you to understand. Let me make the clear picture. Okay, so this is your carrier signal, this is your message signal. Okay, now you are going to do the modulation. Okay, so this is your signal as it is here, the amplitude here, basically your signal is, and we are now we'll change the phase. Okay, so we'll change the phase. Okay, see, again here you will change the phase. Okay, so this is how here we are changing the phase. If you take an example for the phase modulation, I can show you in a very simple one liner. Okay, that what exactly the phase modulation we are doing. Okay, so we are changing the phase, and whenever we are talking about the phase, so it will be in a degree. Okay, so 0 to minus 180 degree. Okay, we are changing the phase. Okay, we'll go on much more detail. Okay, once we will be going through in depth. Okay, so basically here we are changing the way. Now when we talk about the digital modulation, so there are basically three types. Okay, and here I have added simple figure. Okay, amplitude modulation. See here, amplitude, we are changing the amplitude. Okay, here you can see, let me write in it. Okay, yeah, so here we can see this is the frequency. Here we are changing the frequency. Okay, wherever, based on the pulse. Okay, this frequency is different. Here we are changing the frequency. Okay, based on the amplitude. And here we are changing the phase. Okay, so this is in one phase. Here we have changed the phase. Okay, so in this we are changing the phase from pos c degree. Okay, so this is what the three types of modulation. Will go much more in detail later. Okay, now we will go with this digital about the digital modulation, where we will discuss ASK, FSK. And so in digital modulation, what exactly we are doing? Okay, in which, in this particular, digital signal is used to modulate a carrier signal. Okay, so there are basically three main type of this digital modulation: ASK, FSK, PSK. So whenever I'm talking about the ASK, very simple, in a simple word. Okay, in detail anyhow we will do have a separate video. Amplitude shift keying is a type of digital modulation in which the amplitude of the carrier, okay, in this the amplitude of the carrier is varied in accordance with the data. Okay, so basically here the game of binaries 1 and 0 will be there. Okay, whenever I am talking about the digital modulation. Okay, so see, in this what exactly happening, let's take, so we are considering 0 and 1 volt. Okay, so this is 0, this is going to be 1. Okay, 0. So basically in this particular, so 0 1 0 1 0 1 1 0. So this is the representation of the binary sequence. Okay, and whenever I'm talking about the ASK, so this is how exactly it will go. Okay, so here we are varying the amplitude. Okay, this is what exactly we are doing in a ASK. Okay, amplitude shifting, we are changing the amplitude, we are shifting the amplitude, or this is the example you can see we are changing the amplitude. Okay, based on zeros and 1. Okay, now whenever I'm talking about the frequency shift keying, okay, so in this particular, for this particular, see, in this we are varying, suppose this is the frequency for 0, for 1 we have changed. Okay, then again, so basically in this, based on your zeros and 1, we are changing the frequencies. Okay, so frequency shift keying is a type of digital modulation in which frequency of the carrier is varied in accordance with the data. Okay, so example of frequency shift keying is like BFSK, that is binary shift frequency shift keying. Okay, in which carrier signal is shifted between the two different frequency to represent 0 and 1, which I have told you. Okay, in a very simple manner. Okay, consider it very simple. Anyhow we will go in depth multiple time, I'm telling this. And the last one is the phase shift keying. In this, the zeros and 1, we are changing the phase. Okay, so suppose for uh, Let me take the first example on this, then it will be easy for you. Okay, or you can see for ones, okay, the phase is not changed. Now for 0 it is going to change the phase. So you can see the example. I think it will be better example. Okay, try to understand. 1 0 0 1 0 1 1 0. Okay, now we need to apply the PSK here. So let's see. So in this, so for 1 0 minus 1, so this is the signal for 1. Okay, now for 0 I need to change the shift. Okay, change the phase. So for 0 we are going with this particular. Okay, okay. So now for 0 we have gone like this. For 1 we need to again change the phase. Okay, again 0, then 1 1. Okay, so likewise we need to go. Okay, so again 0, so we'll change the phase. So here we are changing the phase. This is what we call it as a phase shift keying. Okay, very simple and layman language, try to understand. Okay, so this is the today's video all about. I will create the video on each in a depth. Okay, with the calculation and all. Okay, so thanks everyone, hope you like the video. This is the basic video. Okay, and we'll go with the advanced video mode. So do subscribe our channel. Okay, and we are going to have one batch is going to start. Okay, on 20 there is a demo on 24th of December 2023. Okay, for our LT 5G and ORAN protocol testing course, please do uh, subscribe that demo. Okay, register for that. The link I will provide in the description, and if you want to pursue that, please do join and enroll. Thanks.